Hey guys, so I wanted to do a quick video today to show you a project that I've been working on this last week. Being stuck at home, I have a bunch of things that I've kind of collected with projects that I've done. One of the things that I love is the Adafruit Feather platform, and I've got an entire box right here that has a whole bunch of different feather wings. One of the things that I did get a few years ago was the infrared thermal camera that they originally had, Adafruit originally had with the Feather platform. And it got me thinking that I know a lot of the businesses that are reopening in China with COVID-19, and a lot of these kind of countries that are starting to open businesses again have been using thermal imaging cameras to detect abnormal fevers from people who are coming into a business. Now there are some commercial grade cameras. Adafruit's actually selling a few of them now. They're just starting to stock some of those for when we start opening businesses as options, but they can be very expensive, and definitely for large volume things like public spaces, airports, or public transit, where you're going to have a lot of people coming through very quickly. It is really convenient to have these systems in place, and they can use a lot of machine learning algorithms in order to do facial detection. And based on data that I've seen from a lot of these websites, what they do is they look at basically a person's eye socket, and that's where you get a very specific reading from the person, and based on a couple of different agreed upon thresholds, you can determine if a person has a fever that would indicate that they were sick. And it's definitely, a lot of these things, they aren't 100% accurate. So it's not like you would just have this be a system that would identify if someone's sick or not, and then do something with that. It's something where you would flag a person for going to have a non-contact temperature reading done with them. And it began started to have me think about what smaller businesses might be able to do to kind of get a simpler thing or a similar thing. So what I've done is I've taken the TTF display. Well, let me show you what the hardware is for this. So basically I'm using this CCD right here. This is works just like a regular digital camera. It's really low resolution and low refresh rate though, but it only reads, instead of visible light, it reads infrared radiation. So this is going to read the amount of heat that is coming off of an object. So basically you can think of it as like a thermometer, but that gives you visual information. Now, this isn't highly accurate. The data sheet says it's accurate to about 4 to 5 degrees, plus or minus. But I mean, we're looking at, most of the data says that we're looking at a variation between normal temperature and someone having a fever of about 10 degrees. So it's better than nothing for a lot of stuff. The other thing that it's using is this TTF display, which is just a way where I can plug that module directly into this screen right here. Of course, I am using a microcontroller as well. In this case, I'm using the 32U4 FeatherWing for the microcontroller that handles the logic going from the screen and actually telling the screen what to display on it. So I'm going to go back to just my bench camera, and you can see I can put my hand in there and you can see it turns green. I have it dialed in to a very specific threshold of temperatures that it's looking for, and that affects the color that's displayed on the screen. Now the background is going to be a colder temperature, so that's going to typically show up as like a blue or and then I have it dialed in so that normal body temperature is going to show up as green or yellow. So you can see as I put my hand in there, my hand is green. You can see, I mean, it's high enough resolution you can tell that like I have my finger in there. Now I'm going to show you what happens when I put in a higher temperature. So the temperature that I'm using is actually, it's my soldering iron. So my soldering iron is currently dialed into the lowest temperature that I can set it, which is 120 degrees Fahrenheit. And what I'm going to do is I'm going to take my iron and I'm going to stick it underneath here, and you're going to see that now that is coming up with an alert. So you can see now that is above the threshold of the temperature that we're looking for. And I set it up so that if there is something that is above a normal temperature for a person, that it will start to get more into the orange and red. Of course, if they have basically what the target temperature is, that's kind of been understood, indicating that you probably have COVID-19, that will turn red. Anything above that temperature will turn red actually too. So the other thing that it'll do is it'll actually display the temperature on the camera. You might have seen that white text that was on there. And oh, there we go, it gets better on the tip. And then, of course, you probably heard that buzzer that goes off that indicates that it has detected something in the view of the camera that exceeds the temperature, the ideal temperature that we're looking for. Now, this is something where we wouldn't necessarily, so this could be a standalone device that could be at like the entrance of a space. I'm actually going to be talking to my makerspace here in Seattle about when we start reopening for doing some minimal workshops and allowing people to come into the shop on a very minimal basis, to start have this basically at the front door so that everyone who comes in, they have to walk up to it and possibly have instructions on the front of the device to tell them what they need to do. And then basically, you know, if the alarm beeps, then, you know, we know that we need to read that person's temperature just to confirm, and then probably have a conversation with them about having them go home and come back, or make the decision if we just need to provide them with more safety gear than maybe we would normally. So this is just for me, kind of a project that I thought would be really cool for helping out some of the, you know, it's affordable enough to where a lot of the smaller businesses or people who can't really afford like a $400 to $500, or even some of these things are like up in the $1,000 range for those thermal cameras. This is something that will kind of do a bit of the same thing, but you know, maybe cost you $100 or less. Now that being said, unfortunately, all of the supplies for this, at least the thermal camera, is out of stock. They're at Adafruit, so I don't know if they'd be able to have it back. I know they do have a newer version of that camera that may be available in stock. Right now, they aren't shipping a lot of stuff from Adafruit, but they're focusing more on the PPE manufacturing and distribution in New York, and less with the electronic stuff, or making new electronic stuff that isn't critical. But they do have partnerships with DigiKey, who is a reseller I haven't checked there, but it is a possibility that maybe DigiKey has a few of these parts in stock. But I'll list some of the parts that I used, and I might flush this project out a little bit more and even post like a GitHub repo or something so people can download the code. The code is actually really easy. It's just based on the library for this device, just the basic example that they have in the Arduino library. And you can see, of course, my computer screen is coming up. It's got a fever, but yep, that's all it is. And this is all battery powered as well, but it can also power the regular battery. So that's all I wanted to show for now. And everybody stay safe, and thanks for watching.